Hello guys, welcome back to my channel. In today's video it's about integer arithmetic by using assembly language. So let's take a look at the example. So here we have data section with some variables defined. Most of them are bytes. So first, second and output without overflow over here. And here intentionally with this value 255 and 1 for the bytes, and here for the system some variables, and then the text section moving byte first number into AL register. So the first 8 bits are stored. This byte is stored inside this register, the low half of the racks register, just the 8 bits, and then adding the second number inside the same register and moving register into the output, then resetting to 0 to clean any data inside this register. And here we have with overflow, and once again with overflow but immediate values instead of variables, and exiting from the assembly, from the executable. Now the next part is by assembling and compiling the file. For the assembling I am using this compiler, G option for debugging by using dwarf format of the executable and linking format 64 for Unix systems, and the output. So this is the output file, and that is the assembly. And then with the linker, option G for adding the debugging information into the object file, and the output. So what is stored here will be translated into executable with this name, int, with the debugging information. And by using GTP, let's start the executable. And let's see the numbers, line numbers. So we need to start with breakpoint 25, because here is the start of the move instructions. Let's run, and I want to watch about several registers. Watch for IO, the 8-bit low part, the 16-bit, and the 64-bit racks register. So this first line byte second known, we have 20. Yeah, but it's not executed, it's actually executed this one. first num, so it has 10, and in each of the watching point we store the value 10. On the next one, after executing second num to add with IO register, we have new value 30 in each of the registers and storing it in byte output. Then resetting, new value 0, all of them. And here we have -1. In the 16-bit we have this value, and in the 64 this value. That's because in each, after 127, the value becomes -128 until the value is 255. Then one more time it's 511. We have this negative value because it is overflowing. It's like a loop. When reach the point 256, then resetting back to 0. Some incrementing of the IX register, output resetting, and here for 127, when we incrementing the register from 127, we got -128 until it reaches of this register 256. It becomes -1, then 0. Sorry about that. And here for the exiting, this is a simple example of adding integers with different register sizes. Actually one register, the racks, just with different sizes, parts of it. If you have some suggestions or questions or anything you could ask, let me know in the comments below. Until next time, bye bye.